Let's take a look at another way SpaceClaim is great at reusing data, even from generic files like STEP. One thing that's very common in the simulation and analysis fields is computational fluid dynamics, or CFD. And that's when we have a part or an assembly that has some sort of internal volume. Usually we have air, gas, some sort of liquid passing through certain chambers, and we want to take a look and analyze the flow, basically how the different materials will pass through, also the effects they have on thermal stress and strain. And in order to do this in other programs like ANSYS, COMSOL, even within some CAD tools like SolidWorks, we need a solid representing this internal cavity here. So what we have in our Prepare tab, where we prepare models for analysis, is a tool called Volume Extract, and it helps automate the extraction of the solid from these internal volumes. So the way the tool works is it just allows me to kind of think intuitively, specify the boundaries where I want to cap off these volumes. I know that there is one set of chambers between these four inlets, so I can use those as a method of specification in order to tell SpaceClaim where to create this volume. So I just use these faces as boundaries, and here we can now see this volume extract, and I could go ahead and hide everything else in the model here, and now we can see this solid created from that internal cavity. And the thing that's great about this solid is it's just like any other solid in SpaceClaim. I can edit it directly, remove detail, change sizes, even set up a group with a driving dimension, which can be used to run an optimization study when transferred out to another piece of software like ANSYS or COMSOL. Now, also built into this tool are some methods of diagnosing when a volume extract doesn't work. So I'm going to do one for the larger volume here. So we have a hole on that end, two on this end, and I'm just going to give SpaceClaim a little hint, tell it which side of the boundaries to look on. And I'm going to go ahead and click the check mark here. And a lot of times we had users, they would click the check mark and either get an error saying not all boundaries have been capped, or after creating this volume, they'd go to hide everything, and it wasn't really the extracted volume. It's really the entire body plus the extracted volume, and that's not what we're looking for right here. So I'm going to undo back, Control Z, which is always great being able to undo. And what we did was we added in the ability to see the volume extract process in action and rewind it. What we found out most users were doing was they missed a boundary. Maybe they had an engine block with hundreds of ports and they missed one. So here what I'm able to do is rewind this volume extract process, and I could see that somewhere around this area here it started to leak out. And if I go ahead and take a closer look, it looks like there's a small little port here that I missed. So I could go ahead and add that into my selection for the boundaries, recreate the volume extract, and then we can go ahead and hide the rest of the assembly so that we can see this extracted volume. Now, in addition to being able to edit the volume directly, if I go ahead and decide that I'd rather edit the part, so I need to extend the length, maybe we want to change the diameter, what I could do is I could have the extracted volume update itself based on those initial boundaries, and it will refit itself to the updated model. So very easily update the original and then have the volume update. And we could also update the volume and then manually update the original model to reflect those changes. So this can be used for fluid analysis. Sometimes extracting this volume is also great for manufacturing, for creating fixtures or even a mating part. Thank you.